So we've finished learning about radiation and radioactive atoms. The next thing we'll do is go back and learn some more details about different types of atoms. And we're focusing on electrons in this one. So to start us off, we'll start with a bit of a story. Back in the day, in the early 1900s, so in about 1914, this was the model of an atom that all the evidence was pointing to at the moment, or at the time. So we knew there was a nucleus, and we knew that there was a lot of empty space in atoms, and we knew that electrons were flying around the nucleus. So everybody accepted that, but as always in science, everybody was working and experimenting and discovering new things, and someone who made a really important discovery is this guy called Niels Bohr. So he was from Denmark, and he was working with all of the best physicists studying atoms at the time. And through doing some experiments, him and his partners, they figured out that actually electrons don't just fly around the nucleus at random. They actually have different energies, and different electrons with different energies orbit at different distances from the nucleus. So his main discovery was electrons have different energies. And then, secondly, that electrons further away from the nucleus, they have higher energies than ones closer to the nucleus. So electrons further away have higher energy. So looking at this model of an atom here, we can see that the two electrons close to the nucleus, they have a lower energy compared to these ones on the outside, which have a higher energy. So this guy, Niels Bohr, he basically came up with a brand new model for what atoms should look like. So from then on, we started drawing atoms with these orbits, just like planets orbiting around the sun. And these orbits are called shells. So after that, further work, they started to discover that shells, each electron shell, can only hold certain numbers of electrons. And you might have seen that in every picture of an atom that you see, there's only ever 2 electrons in that first shell. So shells can hold increasing numbers of electrons. The first shell, it can hold 2 electrons. So number of electrons. The E with a little minus, that's just the symbol for electrons. The second shell, it can hold 8. The third shell can hold 18. And the fourth shell can hold 32. So there's always going to be Well, if an atom has at least 2 electrons, we'll find 2 in that first shell, and then we'll have to move out to the next shell, and that will hold the next 8, and so on. So electrons always fill, or they always live in the lower energy shells first. They always inhabit or live the lowest energy shells first. Unless they get some energy and become excited, but that's another story which we'll learn about later. So let's look at some details of some other different elements. If we look at lithium, lithium is element number 3. So it's got 3 protons, and a common isotope of lithium has 6. Well, a mass number of 6. So it's got 3 protons and 3 neutrons. So let's go about drawing an atomic diagram of a lithium atom. We're going to have 3 positive protons, 3 neutrons, which are negative, and then we remember that the protons always equals the number of electrons in a stable atom anyway. So that's what we'll look at now. Sorry, not a stable atom, a neutral atom. One that doesn't have a charge. So we've got 3 electrons, and remembering that the first shell can only hold 2. So we'll draw our first shell, and we know there must be just 2 electrons in that first shell. Now that shell's full though, so the third electron will have to fill into the second shell. And that's all 3 of our electrons. So what we can do from here is, instead of needing to draw this diagram every time, we write something called the Electron Configuration. And it shows the number of electrons in each shell. So for lithium, the electron configuration is going to be 2 electrons in the first shell, and then 1 in the second. So we use commas to separate each shell. First shell and second shell. We'll do another example as well. So another common element is sulfur. It has the atomic symbol S, and sulfur is number 16. So it has 16 protons, and the most common isotope of sulfur also has 16 neutrons. So 32 will be the mass. So to draw sulfur, let's just skip drawing the nucleus, and we can just write S as the nucleus. But for the electron shells, we're going to have to count and check that every shell is full. So the first shell holds 2 electrons. And by the way, we have 16 electrons that we need to fill. So we've got 2 in the first shell. We know the second shell, it can hold 8. So 1, 2, 3, 4, 6, and 8. So we're up to 10. That means we're going to have a third shell for sulfur, and we've got 6 left over. 5, 6. So here's our atomic shell diagram of sulfur. and then we can do the electron configuration as well. So we're counting for sulfur, we have 2 electrons in the first shell, then we've got 8 in the next, and then we've got 6. So the more recent view of atoms is that electrons live in shells. They're still flying around at the speed of light, but they're in particular shells and they have particular energies.